Dear students, today we'll discuss about electric field intensity and electric field lines of force. So first we start from electric field. Field is not a new concept for you because you have already read in class 11th gravitational field. You have a little knowledge about field. Still I am explaining you what is electric field. I am giving one example. Suppose in school your teacher is little late to your class and nobody is inside the classroom, only you people are sitting, you and your friends, 40-45 students in one classroom. Then generally what you do when the teacher is not in the classroom? You do chit-chatting among yourself. Some naughty students throw water on others. You also roam inside the classroom. So many mischief things you do at that time. Why you are doing like this? Because you are feeling totally free. You know, no one is here to tell us, no one is here to control us. So you move here and there inside the classroom, lot of noise comes from the classroom. This is the general situation when the teacher is not present. But when your teacher just come towards classroom, just enter through the door, then what happened at that time? Immediately all your friends, you sit like ideal students. Very calm, disciplined, all of you sit like ideal students. Now can you able to move inside the classroom? Now can you able to stand in the classroom? Can you able to make a little amount of noise? Not at all possible. But why this happens? Because now you are not free. You are not free to do anything. Your teacher is there. So you are feeling some force due to the presence of your teacher. Why this happens? What do you think? If one of your friend is not present in the classroom on that day, he is roaming outside the school boundary, or he may be at his home, does your friend feel the force of the teacher who is standing in the classroom? No. If your friend is roaming outside the school boundary, also he is feeling the force of the teacher inside the class who is now standing in the classroom? No. This happens. So what happened here? Only you and your friends, those who are sitting inside the classroom, they feel the force, they feel they are not free, they feel the force of the teacher present in the classroom. But your friend who is outside the school boundary is not feeling the force of the teacher. So that thing I am going to teach you today about the concept of a field. What field comes here? So the teacher is creating a field there inside the classroom. Due to the presence of the teacher, the classroom is now modified. The space is now modified due to the presence of the teacher. So that is called as the field. When the teacher is not there, the situation was different. When the teacher is there, the situation is now different. The situation is now modified when the teacher is there. So this is the concept of the field. The same thing happens, you see. So one charge Q is present. This is charge Q. Charge Q is present here. So around it, now due to the presence of the charge, one field is created around it. Just like due to the presence of the teacher, one field is created there inside the classroom. within the classroom walls, one field is created. Due to the presence of this charge, one field is created around this. Whenever any charge, suppose one charge I will tell, another charge, suppose Q dash. Q dash, another charge is here. Now it is moving like this. Suppose this is one positive charge, your Q dash is a negative charge. If it is moving like this, can Q dash move like this? Can the Q dash able to move like this? Not at all possible. If plus Q is not here, then Q dash will move its own way if it is moving. But if plus Q is here, what happen now? The plus Q will not allow Q dash to move like this. Why? This plus Q will attract this minus Q. Plus Q will attract this minus Q and will change its motion. Minus Q cannot move in its own way. Plus Q will not allow. Because this situation, this region is now modified due to presence of this plus Q. This situation is now modified. So what is the field now? What do you mean by field? What definition will write for field? So electrostatic field or electric field is defined as, you can write in your notes copy this definition. Electric field is defined as, it's a region, it's a space around a charge within which when any charge enter must experience the force of this charge. So electric field is defined as space around a charge within which its force can be realized by other charges. This is the definition. Its force can be realized by other charges. So this is the electric field. Now it has a field around it. If any charge will enter in it, it will must affect that charge. This situation, this region is now modified. It's a three-dimensional space, not two-dimensional. It's a three-dimensional. If the charge will be here also, it will be affected by this charge. It's a three-dimensional space. So this is about electric field. All of you now understand what is the definition of electric field. What is the field? It's a region. If the charge will be here, then it may not affect. It will be negligible force will act, because electrostatic force exists up to infinite. But if the charge will be here, force will be very much negligible. So it may not affect. Only it enter into a region, then only this charge can apply the force and will affect. Then the field starts. When you are inside the school campus, if your teacher is sitting in his common room, then you are feeling very little force, very small force you are feeling. Teacher is in the common room, you are in the school canteen. At that time the force is very less, negligible force means almost teacher has no field towards the canteen. But when you are going close to your teacher or when the teacher is inside the classroom, then you are feeling the force. You are affected by the force of the teacher, the presence of the teacher. You are realizing the field there. So the classroom is the field of the teacher, not outside the school boundary. But inside the school boundary the force is very less. Still there is a little amount of field exists, but the strong field exists inside the classroom. The same thing here. This is the charge. So this is the electric field around this charge. If anybody will enter, it must be affected by this charge. This is called field. The modified space around a charge within which it applies its force on any other charge. Now we come to another point. This is electric field. What is test charge? Test charge. Symbol we write for test charge Q0. What is test charge? It is always taken as unit positive charge. Remember, it is always taken as unit positive charge. Test charge. It is taken to test the presence of electric field. Whether electric field is present or not. This is called test charge. Similarly, you have taken in 11th class test mass. Laterally take test pole, same thing. So test charge is unit positive charge. The question may come to your mind, what is unit? Unit means its magnitude is 1. Magnitude is 1. It may be 1 coulomb, maybe 1 microcoulomb, maybe 1 nanocoulomb. So magnitude is 1. And the question may come to your brain, sir, what will take then? 1 coulomb or 1 nanocoulomb? Please specify. Okay, that one I will tell just in the next sentence how much will take. Then positive. Positive. Why the sign of this test charge is positive? This question has no answer. Please don't ask this question to any teacher. Why? Can it be negative? No. It is taken as positive. It is conventionally taken. Purely conventionally taken. So don't ask this question. If you will take it negative, no problem. But we have to change the whole book. It is conventionally taken from the starting as positive. So it has no reason why it is taken positive. Simple convention. If anybody lacks, you can tell it is conventionally taken. No reason it has. So this is the unit positive charge. It's called as test charge. Now will come one question you may face in exams. One question comes here. The magnitude of the test charge is infinitesimally small, very small in comparison to source charge. Source charge means I am telling the field, the charge which has its own field. This is the source charge which has its field. To test its field, I will take test charge. Up to which region its field exists, I will take test charge. So test charge magnitude is very less, infinitesimally small in comparison to source charge. You may ask, so why? Now come to the point. Infinitesimally small means how much small? Suppose this is 1000 coulomb. You can take the test charge as 1 coulomb. If this is 1 coulomb, source charge is 1 coulomb, you can take the test charge as nanocoulomb. Now you understand how much will take the test charge? But magnitude should be 1. Okay, if this is 1 microcoulomb, you may take it 10 to the power minus 20 coulomb. But the magnitude will be 1 always. Okay, 1 then some unit, no problem. So this is about the test charge. But why the magnitude of the test charge should be infinitesimally small? I told you this question may come in exam. What actually right? We are going to test the electric field of source charge, not the electric field of test charge. One example I am telling you. When the teacher is inside the classroom, up to what region the field of the teacher exists, you want to know? Then who will be taken as a test buddy at that time? A student will be taken as test buddy, or school principal will be taken as test buddy. Now you got my answer, I think. If the student is taken as test buddy, then the from which region the student experienced the force, then from that we can test the field of the teacher. But if we will take principal as the test buddy, then what happened there? Then field of the principal will be tested. So the body which will take to test the field should have negligible. Why? Should have negligible magnitude charge. Why? Because its own field should not affect the field of its own field, should not affect the field of source charge. If this is the test charge here, it has also its own field. Test charge also has its own field. Test charge should not affect the field of source charge. So it has also its field, but its field is very small. It should not affect the field of source charge. If an exam the question will come, why the magnitude of test charge is taken as infinitesimally small? You can write the answer. What answer will write? It is taken infinitesimally small because its own field, the field of the test charge, its own field should not affect the field of source charge. So this is about test charge. Symbol is Q, not will write. By default it is always positive. Now come to one quantity, electric field, important quantity, electric field intensity. It is also called electric field strength, intensity or strength. Intensity, or this is called also strength. Electric field strength or electric field intensity. It's a physical quantity. Symbol for this will write E, electric field intensity. So why we need electric field intensity? Same example also I am giving you. When inside the classroom, one example I am giving you in this portion. If one naughty student is there, where he will prefer to sit on front bench or in the last bench? Why do you prefer to sit in the front or in the last? I think you got the answer. So he always prefer to sit in the last bench. Why? Because when he is sitting in the last bench, then force will be little less. Teacher is standing, distance is more, force will be little less, and teacher will have little influence on the last bench. So always naughty students inside the classroom prefer to sit in the last bench. Why this happens? If you ask the students, on the front bench force always is more. The teacher's class strength, the teacher's force strength, where the strength is more, intensity is more, on the front bench the strength is more. Force experience is always more on the front bench, but strength, force is less always in the last bench. So where more force act, where less force act? I want to also know this electric field. Plus Q charge is here. Here force will be how much? Here force will be how much? Here force will be how much? I want to know. If I want to know, then I have to read this quantity, electric field intensity or electric field strength, to know at which point how much force acts. This intensity will help you like this. But how can we define this intensity? At this point, you see, if I want to know how much force acts here, I have to read intensity. How to define intensity? How can you define electric field intensity? Suppose at this point, this is a point, at this point, how can you define electric field intensity? Point P. Electric field intensity at any point is defined as force experienced by unit positive charge placed at that point. This is the definition you can write in your copy. Electric field intensity at any point is defined as force expressed by unit positive charge placed at that point. Unit positive charge means test charge. If I want to know where the force is more, I will take one standard charge, that is, you know, we are all, our standard charge is test charge. I will take test charge. I will place the test charge here. If I want to know here, suppose at this point, I will place the test charge here. Now see, at which point force will be more? Okay, you are telling the answer, force will be more at point P because distance is less. Force is inversely proportional to distance. So more is the distance, less is the force. So here force will be more, here force will be less. That means here intensity is more, here intensity is less. So what the intensity gives us? Intensity is nothing but force. Intensity is nothing but force. It is equal to force. But force which is experienced by unit positive charge. So that is the intensity. The force which is experienced by unit positive charge. It varies from point to point because force varies from point to point. So now you got my definition, I think. So intensity, its symbol is E, but I like E vector. Why E vector? Now you see, it is nothing but force experienced for unit positive charge. So E vector is equal to F vector by Q naught, force experienced for unit positive charge. So this is the general formula of intensity. One formula you got now here. General formula of intensity. As force is a vector, intensity is also a vector, because I told you intensity is not any difficult quantity. Intensity is the force which is experienced by unit positive charge placed at a point. So this is the intensity. Now you got it. So what will it is a vector quantity. From this you got it is a vector quantity because it is force and its SI unit. SI unit C Newton per Coulomb. It's a CGS unit. CGS unit I have told you two types. One is ESU, one is EMU. ESU this is Newton per start Coulomb. This is Newton per Coulomb. This is ESU. This is EMU. 2 units. And it's a dimensional formula also. You can find putting the force dimension divided by charge dimension. If you want, you can find its a dimensional formula. Force dimension M1 L1 T minus 2. Charge dimension you know A1 T1. And you solve it, you will find the dimensional formula of the intensity. This is the complete address of the intensity. Now we go to intensity of point charge. As we are discussing only about point charge now, so now we will discuss intensity of a point charge. This is the point charge. It has its field around it, and we have the curiosity to know at which point the field is strong, at which point the field is weak. And to know that, we have to read electric field intensity. I want to find out the electric field intensity at this point. P is a point, but Q is the source charge. Where point P is at a distance R. Point P is at a distance R. So, how will you find the intensity here? What was the definition? Force experienced by unit positive charge placed at that point. Now you place one unit positive charge. What is the force experienced by unit positive charge? What is the force experienced? Okay, you are thinking the answer this one. K Q Q naught. I am using Coulomb's law. R square into R cap. I am using the direction here also. I am writing in vector form. R cap. Then what is the intensity formula? E vector is equal to F vector by Q naught. Q naught cancel. It is coming K Q by R square into R cap. So this is the intensity. K Q by R square into R cap. So this is the formula of intensity due to point charge. But the question comes here, how intensity varies with R? Intensity varies inversely proportional to the square of the distance, just like the force. How will the graph? Now graph will be like this. E versus R. The graph will be like this. And if you tell E versus 1 by R square, as we have done F versus 1 by R square, same thing. This is the graph. How intensity varies. But this is the intensity due to point charge I am telling you. Intensity general formula is this. E is equal to F by Q naught is the general formula of intensity. But this is only intensity due to a point charge. Now let us see. We got the dependence. Now let us see where is the direction of R cap. If intensity is a vector quantity, where is the direction of intensity? Now let us see. Direction of intensity is where? Where is the direction of R cap? This charge is supposed positive. I am taking this charge as positive. I have not taken any sign of the charge. Now I am taking this is positive. This test charge is by default positive. It is always positive. Now you see where is the direction of R cap? Where is the direction of force now? So on this test charge force acts. Here force acts. And this is the test positive charge. Positive charge, they repel each other. So positive repel that test charge. Plus Q repel the test charge. This is the direction of force. If this is the direction of force, then this is also the direction of intensity. So now you see. So if this is plus Q charge, where is the direction of intensity? You just remember it, away. Remember the word away. For plus Q charge, direction of intensity is away. If this is minus charge, now this minus Q will attract this plus Q. This is always plus Q because this test charge. Minus Q will attract plus Q. Where is the direction of force? Here. That means this is the direction of force, means direction of intensity. Force direction means this is intensity direction. Intensity. What happened here? Minus Q will attract plus Q in this direction. So where is the direction of intensity due to minus Q? Towards. Towards, you remember. One is away, one is towards. Where if plus Q, if this is plus Q charge, here intensity is where? Away. If this is minus Q charge, here the intensity will be where? Towards. Remember like this. For plus Q, intensity will be away. For minus Q, intensity will be towards. These two things you remember. Away and towards. So this is about the electrical intensity due to point charge. Now we'll come to the next. What is the significance of this intensity? Reading the intensity, what will do? For the significance of this, suppose this point, I will tell intensity. Here one electric field exists. I don't know where the source charge. I have no information about source charge. But it is written only electric field at this point is 10 Newton per Coulomb. Direction is somewhere I can. 10 Newton per Coulomb, the intensity. Here. Now what happened? What is the physical significance of this? Can you tell me what is the physical significance of this? What answer is coming to your mind? 10 Newton per Coulomb means if I put 1 Coulomb charge at this point, 1 Coulomb charge at this point, it will experience how much force? 10 Newton force. 10 Newton force. Direction will decide. If I will put 1 Coulomb charge here, it will experience 10 Newton force. This is the significance of intensity. Again I am telling you, 10 Newton per Coulomb. From the unit also it is clear. If I put 1 Coulomb here, I will make 1 Coulomb to sit here, it will experience 10 Newton force at this point. So if one Q charge is placed here, this is Q, is any other charge, it's not the source charge. If one charge Q will be placed here, how much force will then experience? I am telling you, if 1 Coulomb placed, how much force experience? 10 Newton. If Q charge placed, how much force it experience? You will tell sir Q into 10 Newton. Unitary method. If 1 Coulomb charge placed, 10 Newton will experience because intensity is given this. If Q charge is placed, then Q into 10 Newton force will experience this much force. This much force it will experience. Okay. So that means 10 is nothing but E. So can I write F is equal to QE? F is equal to QE. One formula you got from here to solve many numericals. F is equal to QE. If I write vector, this E is vector, this F is vector. So, if at a point intensity is given to you and one charge Q is placed at that point, what is the force experienced by the charge Q? F is equal to QE. This is the force experienced by charge Q. By this formula you can obtain the force, you can calculate the force. Now you see, Coulomb's law is not required to find force. Coulomb's law you use when source charge is given and affected charge is given, or when two charges are given. But if intensity is given, also you can find the force experienced by any charge placed at that point by this formula. You remember this is one important formula. You can write in your formula copy. F is equal to QE vector. So F vector is equal to QE vector. When charge Q is placed at a point of intensity E, force experienced F vector is equal to QE vector. But where is the direction of force? Where is the direction of the force? You see, if this Q is positive, it will be plus QE. What you mark here? If plus QE, where is the direction of force? Along the direction of intensity. Force direction is along the direction of intensity. You can write one thing here. If Q is positive, force is along the direction of intensity. If Q is negative, force is, you see minus sign is here, force is opposite to direction of intensity. Force is opposite to direction of intensity if Q is negative. I am giving you one example to you. Now you see here, suppose here intensity direction is along x-axis, means I cap. This is the direction of intensity. If I put one proton, if I put a proton here, magnitude is suppose here, if I put a proton, then what much force act here on the proton? Plus EE. Plus E, proton charge is plus E plus EE. But if I put an electron, this is proton force. If I put an electron, minus EE. Now can you mark here? This is EE, electric field is along I cap, and this is minus EE, and electric field is along I cap. So it becomes EE minus I cap. What to mark here? If I place a proton here, proton is positive. Force will be along electric field, means along x-axis. If I put one electron here, electron is negative. Electron is negative, so force will be opposite to electric field. You see, minus I cap. So at a point, if you place proton and electron, you see both experience the same magnitude force. But what is the direction of the force? Proton experience along the electric field positive I cap, electron experience the force opposite to electric field negative I cap. You see the behavior of proton and electron. From the starting I have told you, plus minus sign is only given due to their opposite behavior. If proton will move along x-axis, electron will move along negative x-axis. They move in the opposite direction, opposite behavior. For this plus minus sign is given to them. So this is the significance of electric field intensity. Based on this formula, you can do any questions. One important question is there in your NCERT book, additional exercise, first question. This is very important. Millikan oil drop experiment question. Very important question always comes in exam. You can try. Additional exercise, first question is very important from NCERT book, first chapter. Now we will come to the another part. Electric field lines. Electric field lines or lines of force. What do you mean by electric field lines? If one source charge is here, suppose it has its field around it, you have the curiosity to know up to how much is the field extent. Up to how much is field extent. Okay, now you took one test charge and place here. This is a positive charge, suppose I am taking, okay, positive charge. After some time I will take negative. Now I am taking positive charge. So I have now put the test charge. Test charge by default is positive. From the starting I told you. What happens to this test charge now? If this test charge is free, no other force acts on this test charge. What happens to this plus Q? Plus Q will repel this test charge. And test charge, force act on it. How much force acts? Just before I told you, F is equal to QE. So F is equal to Q naught E force act here. And this repel. So where the test charge will move like this. This repel this test charge, are only one force act, it will move in a straight line and move like this. Move like this test charge. What is formed now? A path is formed on which test charge move. This path is called as electric field lines or lines of force. So what is electric field line? Path followed. You can add the definition. Path followed by unit positive charge placed in an electric field provided it should free to move. It's called electric field lines. Again I am repeating. Electric field lines is the path followed by unit positive charge placed in an electric field or in an electric field if it is free to move. No other force should act on it. No other force, no friction, no viscous force, no other force would act, only one force, electric force of the source charge. Then it starts moving. And the path is called electric field lines. Is there such lines present around this plus q? If 1 plus q is here, is there such lines present around this plus q? No, there is no such lines like that. So these lines are just imaginary lines we are drawing. So these are the imaginary lines. So now you come to how we'll draw these electric field lines. This is for plus q. Imagine plus test charge is here, move like this. Imagine test charge is here, move like this. Test charge is here, move like this, move like this. Anywhere you place the test charge, electric field lines will be like this. So these are the electric field lines due to plus q, positive point charge. Positive point charge. Now I am drawing for negative point charge. You see what happened. I am drawing for negative point charge. If this is negative point charge, now you see. If I place a test charge will be attracted by this. We will move here. I will place a test charge, will be attracted by this. Not required to mug up. You can able to think how we draw the lines. You can draw the lines like this. From where these lines comes, these are just the path of test charge. Just imagine test charge is sitting there. Where it will move? It will attract, minus q will attract, it will come like this. This is for minus q charge, negative point charge. If I tell you to draw for plus q, minus q, two charges are separated like this. It's also called electric dipole, that we'll discuss in the next video, next lecture. Now you see how I'll draw the lines, how the electric field lines will be. And so if I put test charge here, what it will move? You see, test charge is plus. This plus will repel, this minus will attract. It will move like this. One line you got, this is minus q. One line you got. If I place here, this plus q will repel. You may tell also minus q attract, but minus q effect will be less here. If I place here, minus q will attract. Always remember one thing. Which charge you are placing, that is a positive charge. Okay. If I place here, what will happen? Plus q repel, minus q attract. Where it will move? It will move in a resultant path. And if resultant path will be like this. See, this will be the resultant path. Resultant path will be like this. So you can draw the electric field lines due to. So these are the electric field lines will come towards minus q. So they start from plus q and end at minus q. Are they moving from minus q to plus q? No, not at all possible, because test charge is plus. It always goes away from positive and towards negative. The lines of forces are going away from positive towards negative. Now let us draw for plus q plus q. Okay, now let us draw for plus q plus q. Plus q is here, plus q is here. If I place here, it will move. Where it will move? This plus q repel. This plus q repel. If this plus q repel to that side, this plus q repel to this side. Where it will go? It will not go anywhere. So in between, just at the middle, force on it will be 0. If you calculate by superposition principle, it will not move anywhere. There is no line just at the middle. There is no line. But you see at this side, plus q will repel. Let's see at this side, plus q will repel. Away from positive. You see at this side, plus q will repel there. This plus q also will repel. So it will move like this. This line is curved because of the two forces act on it. Due to two charges, two forces act. And we have to do the resultant one. We have to take the resultant one. So two forces act here. You can draw one line like this also. You can draw one line like this. Then you can draw the line like this. But no line will be at the middle. This is for plus q plus q. If I tell you to draw for three charges, plus q, three charges, suppose plus q, three charges will take. Now you see, just they are sitting at the plus q, plus Q on the vertices of an equilateral triangle, how the lines of force will be. So here it will place repel, here it will place repel, here it will place repel. Some students draw like this. So this is actually a common wrong drawing. So here it will not be in this direction, it will be in this direction. You see the resultant force will be in this direction. If you place the test set, it will move in this way. This force, the resultant will go in this way. Don't draw like this first one. That is a common wrong thing. Then you draw, the process will be, lines of process will be like this. You can draw for this also. For this is for plus Q charges. So this is about the point charges lines of force. If I tell you to draw for one charge system like this, many charges are there, plus, lines of forces will be away. They will be away like this, lines of forces. If I tell you to draw for one charge system like this, plane, here this is positive charge, but this is many positive charges are here, and here I am trying to draw negative charges are here. Now if I tell you to draw the lines of forces, positive repel, test charge, negative attract, lines of forces will be like this. They will be like this, lines of forces. And later we will understand that this is called a capacitor system. We will read that in the next chapter. This type of system is called a capacitor. You remember, this is the lines of force inside the capacitor. Two plates are there, and one line also will be like this here. Some line will be like this here. Bending of lines at the edge of the plates. This is one term is there, one word is there. The phenomenon of bending of lines is called dash. Okay, that is called fringing of field. You will see that you may not get in your textbooks. That is called fringing of field. Bending of lines of force at the edge of a plate. It's called fringing of field. So this is about the lines of force. Now we will come to the properties of lines of force. What are properties it has? First property I am telling. These are imaginary lines, always start from positive and end at negative. Already I had explained everything. As they start from positive and end at negative, can they form closed loop? Is it possible? Not at all possible, because they start from positive and at negative. They are not coming from negative to positive again. What is called loop? This is called as loop. If R will be like this is called loop. If R will be like this, also go in this way, from this point to this point, also go in this way. It is not called a loop. It is called a loop. Closed loop, this is called. So this type of situation will not happen in electric lines of force. So electric lines of force cannot form closed loop. 2020 board examination question came, why electric lines of force cannot be closed loop? The answer is because they start from positive and end at negative. This is the question in 2020 board examination. This is simple answer, because they start from positive and end at negative. So this is the property number 2, cannot form closed loop electric lines of force, but magnetic lines of force form closed loop. We will discuss that in the magnetism and matter chapter. Magnetic lines of force form closed loop. Come to point number 3, properties number 3. Suppose one line is like this. At any point on the lines of force, the tangent gives you the direction of force. At any point on the lines of force, direction of intensity. The tangent gives you direction of intensity. At any point, suppose this is a point here, this is a tangent. Tangent provide you the direction of intensity. This is one property. Now come to the next point. Two lines of force never cross each other. Very important property this is. You know in 11th class, two streamlines never cross each other. Here two lines of force never cross each other. Why two lines of force never cross each other? 2020 board exam question. Also this was. Why two lines of force never cross each other? You see, the answer you will like this. If they cross, suppose one line, two line. If they cross at the point of intersection, if I tell you to find direction of intensity, to which line you will draw tangent? If one student draw tangent to this line, this is the intensity. If you want to draw tangent to this line, then this is the intensity. Where is the direction of intensity at this point? At one point, intensity cannot have two directions. It is impossible. So what answer you write? If they intersect, at the point of intersection, two tangents can be drawn. That means two directions of intensity, which is impossible. This is only the answer. You can write in your notes. This is only the answer. At one point, intensity cannot have two directions, so they cannot intersect with each other. Very important property. So then come to property number 5. The region where lines of forces are crowded, intensity is more. The region where lines of forces are crowded, for example, I am showing you, see, this is one line, this is one line, and this is one line. See, this is point A, this is point B, this is point C. One point C is here. I am making it more close. You see, the region at which region lines of forces are crowded? At point C they are crowded. Then point A, then point B. Now you can compare the region where lines of forces are crowded, intensity is more. Now you can compare which point intensity is more. Okay, you are telling the answer. C point intensity is more. Then point A, then point B. This is the comparison of intensity. Comes as also one question, important one mark question. This is. So this is property number 5. Then property number 6. They contract longitudinally, which indicates two unlike charges attract each other. You see the lines of force of plus q minus q. Their length plus q minus q. Their length gradually decrease. Their length gradually decrease. Then become straight. They contract longitudinally. That means two unlike charges attract each other. They exert lateral pressure plus q. They exert lateral pressure. Lines of forces are like this. Exert lateral pressure as if lines of forces repel each other. They exert lateral pressure. This indicates like charges repel each other. This is one property. Now we come to property number 7. Property number 7 you see. They meet the surface of conductor always at 90 degree. Remember, this is a very important property. They always meet the surface of conductor always at 90 degree to conductor surface. Why 90 degree? We'll discuss that in the second chapter. But now you remember this one. They meet the surface of conductor at 90 degree. Next property I am telling you, property number 8. They cannot enter inside a metal. Electric lines of force cannot enter inside a metal. Unlike magnetic lines of force. Magnetic lines of force will enter inside the metal. They present everywhere inside. But electric lines of force cannot enter inside a metal. So this is also one property. Property number 8 I told you. Then property number 9. The number of lines of force start from unit positive charge. The number of lines of force start from unit positive charge is 4 pi. Number of lines of force. You can't do this expression now. After one class you will derive, then you will get it. The number of lines of force start from unit positive charge is 4 pi. So this is also one property from lines of force. So we discussed many properties related to electric lines of force, and each property is important. From each property one question you may get in exam. All properties are important. Sometimes in exam also question asks write 4 properties of electric lines of force, like this. But what I discussed, these properties are important, but some questions are there also in the previous years, just before 3 or 4 years, one question came in the board examination. What are the questions? I am giving you some questions, you can try. +2 charge is placed on metal surface. This is a metal surface. This is a question. +2 charge is placed on metal surface. Recently in previous year questions, within 3 or 4 years you will see +2 charge. Draw the lines of force for the system. You can try this question. Also, one metal is here. This is the center, but one charge is present here. One +2 charge is present here, just at r/2. If radius is r, just at the bisecting of the radius. +2 charge is present here, and this is a metal. This is a sample paper question. CBS, you know, you will be giving sample paper always. Okay, so the sample paper question is very important. Never come in board examination, but it may come. These two questions are very important from electric lines of force. Also, I told you about 2020 questions. So this is about electric field intensity and electric lines of force. Thank you.